To see it in action, I'm back in our REST API project we created earlier, where we previously added Socket.io. And first of all, I'll get rid of that Socket.io part. I'll remove it. I'll remove the Socket.js file. In app.js, I will also remove my routes because we'll have no more routes. We'll not set up routes anymore. We'll use GraphQL endpoints instead. I'll leave the rest as it is for now. Remove that code where I use my routes. And then here, I will not store the server because I will not set up any Socket.io connection. And we can also now remove the routes folder because we'll not use that anymore. So now I cleaned that up a little bit, and now I want to use GraphQL. And for that, I'll install two new packages. The first one is called just GraphQL. This will be required for defining the schema of our GraphQL service. So basically, the definition of the queries and mutations and so on we want to allow. And I will also add Express GraphQL to install a simple server that will do the parsing of incoming requests and so on. Now, if you want to learn more about GraphQL, check out graphql.org. It's a great resource with a lot of documentation on GraphQL and its query language, which, by the way, is clearly defined, and we need a strong rule set to know how we write queries. And there, if you click on code, you also find libraries for all kinds of languages. And if you choose JavaScript, you find the GraphQL package we just installed, which allows us to define such a schema as I mentioned. You find Express GraphQL, and you also find other solutions for other frameworks. Apollo, for example, is super popular and works with any Node framework. It offers more than the bare bone setup Express GraphQL gives us, though, and I want to show you a very raw approach in this module so that you understand all the behind-the-scenes things. Apollo would hide some of these things, so I will instead use Express GraphQL. Now, with that out of the way, we installed that, we cleaned up our project. Now, let's add some GraphQL logic. And how do we do that? First of all, I'll create a new folder named GraphQL, where I will put my GraphQL-related code. And there, I'll add my schema.js file, where I define the queries, mutations, and types I work with in my GraphQL service I'll create. And I'll add a resolvers.js file, where I will define the logic that is then executed for incoming queries. Now in schema.js, let's start with that. There, I'll first of all import something from that GraphQL package I installed. Not from Express GraphQL, but just GraphQL. And that something I import is the build schema function, which allows me to build a schema which can then be parsed by GraphQL and by Express GraphQL. I will export this schema, so I'll use module exports, and then I will call the build schema function, and I will return that schema object this will generate for me. And now here we pass a string where we describe our schema. Use double backticks here, so not single quotation marks, but backticks, to create a string literal, a template literal, because there you can simply write multi-line strings. And now to define a GraphQL schema, in this string we type schema and add curly braces. Please note that there is no colon after schema. And in that schema, we now define a query field, and this now will be an object with all the queries, and queries are the parts where you get data, so all the queries you want to allow. To make it easier to read, I'll now add a separate type for that with the type keyword, which I'll name query. You could name this differently. You could name this root query, however you want. Now in there, you will have all the different queries you can make in the end. For example, you could add one that is named hello, simply a basic dummy query here. Hello, which, let's say, returns a string. This is how you define the return type for a query. You add a colon after the query name, and then the type. And GraphQL knows a couple of types: strings, integers, floats, booleans, IDs, and you can learn all about that in the official docs, of course. So now this is my root query, and this is the return type of my query here. This is now a very basic schema where we can send a hello query to get back some text. Now, that some text now is defined in the resolver. The resolver is an exported object where we now need a hello function, a hello method. So you need a method for every query or mutation you define in your schema. And the name has to match, of course. I have a method named hello here because here I have a query named hello. You don't need a resolver for this query because in your schema you basically set up your root query, which is then made up of these subqueries which now need resolvers. So now we have a resolver for hello, that hello method, and there we need to return a string, right? We expect a string. You can, by the way, also make this string required by adding an exclamation mark. Now, if you don't return a string, you'll get an error. So here, I could return hello world, like this. If I now save that, I have a very simple GraphQL service. Now, before we test it, let's make it a little bit more complex. In my schema, I'll add a new type, and I'll name that test data. The name is up to you. And there I'll have a text, which is a string, and I'll have a views property, which is like, say, an integer. Both are required. Please note there is no comma after these fields. You simply use new lines. And now let's say my hello query should return that test data instead of a boring string. Well, then we can go back to the resolver, and now we need to return an object in there with a text field that should be a string, hello world, and with a views field, which should be an integer. Now we have a valid resolver, we have a valid schema. Now we need to expose it to the public. And that can be done with the Express GraphQL package. In app.js, we now import that. So here, I'll import GraphQL HTTP. You can name this however you want, from Express GraphQL. And let's now scroll down all the way to the error handling middleware. And there, let's add another middleware so that all the other middlewares do apply. And here, I will apply this to /GraphQL. And you could change that, but that is a common convention to use. And I deliberately don't limit this to post requests here. And I will show you why in a second. So please make sure you use here. And then you use that GraphQL HTTP method, which is provided by Express GraphQL, and you pass a JavaScript object to it to configure it. Now, this needs two items to work. The first is the schema, and for that we need to import the schema, which we export in the schema.js file. So here I'll import GraphQL schema by requiring it from GraphQL schema. And I need to import my GraphQL resolver by importing it from the resolvers file in the GraphQL folder. Now we can go down and use the GraphQL schema here as the schema. And we also need to set the root value, which now points at our resolver. So this is now the GraphQL resolver. With this set up, we can start our node server here, and now let's try this out. You might remember that we have to send post requests, right? So let's use Postman for testing. There, I'll send a request to localhost 8080/GraphQL, and that should be a post request. Now in the body of the request, we send some JSON data that describes our query. So we set this to raw application JSON. And here, you send data like this. You send a JavaScript object with a query key. And this does not mean that we send a query and not a mutation. It simply is something which the Express GraphQL package will look for. Inside of these curly braces, you now write the real query, but actually here, this is a string. And then the value here, between double quotation marks, is your GraphQL query expression. And there, you add curly braces, and in between the name of the query you want to target. And if we have a look at our schema, we see that we have a hello query. So we can target hello here, and hello returns us test data, which has text and views. Now we need to define which data we want to get back for that query. And therefore, after the name of the query, we add another pair of curly braces, and in between, we list the properties, the fields we want to get back for that query. We simply separate them with blanks. So here, I could get my text, for example, but not the views. If I now hit send, indeed you should get hello world here. And if you add a white space and then views, you will get the views too. And this shows you the flexibility already. It's one and the same endpoint, but we define which data we want to get on the front end. And it's important to understand that we don't filter the data on the front end. It gets filtered on the server by Express GraphQL in our case, which does the heavy lifting here. And we simply define our schema and the resolver. In the resolver, we return all the data, but then GraphQL on the server will filter out just the data that was requested by the client. This is how GraphQL works in a nutshell. Let's now see how we can add a mutation. We added our first GraphQL query, which allowed us to get data. Let's now add a query that allows us to save data. And for that, why don't we start with our front end, which we used, and make sure that we can actually sign up users so that we can create users, because that sounds like a mutation to me. For that, first of all, let me clean up my front end. I'm not using Socket.io there anymore. So in the feed.js file at the top, remove that open socket import. And then let's remove that logic from component did mount, where I created my socket connection. And let's also remove add post and update post. I'll do that differently later. After changing this, let's go to app.js, which is where we do sign up. And we want to make sure that for the sign up handler, we now reach one of our mutations. And for that, we first of all need to create it. Now, how do we create a mutation? I'll get rid of this resolver. We'll later add query resolvers again. For now, I will get rid of my query here. For now, I only need a mutation. And we add that in our schema by adding mutation here. And then just as with the query, we define a type, which you could name mutation or root mutation, whatever you want. And there you now define the different mutations you want to allow. So here I'll just point at the root mutation. And in the root mutation, I'll add one which I'll name create user. You could name it sign up, you can name it whatever you want. Now that mutation here will actually require some input, some arguments. And that is a different syntax which you now haven't seen before. You can add parentheses after your query name, and this allows you to specify arguments that have to be given to that resolver that will run in the end. And here we could define that we need some user input data, and now we need to define the type of that data. So how does this data look like? Well, first of all, we could of course accept the title of type string, and then another argument which is the email of type string, and then another argument which is the password of type string. That would work too. Or we bundle it in one object which we expect, and for that object we can create a new type. And we don't do this with the type keyword, but there is a special keyword for data that is used as an input, so for data that is used as an argument, and that is the input keyword. And you can now name this however you want. I'll name it user data. And there, how does my user data look like? Or let's name it user input data maybe. How does that look like? Well, that will be an object which has an email field, which is a string that is required. I need that to be a string and I need that field to be there. I also will get a name, which is a string, and a password. Now, this is the data type I'll use here for my argument, create user. And now the question just is, what do I get back after a user was created? Well, there I want to get back a user object. So for that, I'll define a new type, not an input, but a normal type, which I'll name user. There I'll have an underscore ID field, which will be an ID type. It's a special type provided by GraphQL, which simply signals that this is unique and, well, treated as an ID. I'll then also have the username, which is a string. I'll have the email, which is a string. I have the password, which is a string, which I don't require, let's say, because I don't necessarily need to return that. I'll have a status, which is a string, and I'll have my posts. Now that will be an array, and for that I also need to define how my posts should look like. So let me define another type here, the post type, and that will have an ID. That will then also have a title, of course. A post will also have a content. A post will then also have an image URL. And of course, you might notice some similarities to my Mongoose models. There I also defined how the data will look like and how it is connected. We're essentially doing the same here, because this will allow us to then retrieve that data efficiently. So now I have my post image URL. We also will have a creator, which is a user object, and we'll have the created at field. Now, GraphQL does not know dates, so I'll use a string here, and the same for updated at. Remember, we'll get these two fields because in the Mongoose model for the post, we enabled timestamps. Okay, so that is the post model. We needed that because in the user type, we now will have an array of posts. And this is how you tell GraphQL that you have an array of something. You enclose it in square brackets. And that user data is now what I want to return here when I create a user. That is the schema defined. Let's now work on the resolver for that. We have the create user schema. Let's now work on a resolver that allows us to create a user. And for that, in the resolvers file, I'll add create user like that. And now here, I actually get some arguments. You also do so in queries where you get data, by the way. There you could also get arguments, for example, when you want to retrieve a specific post with a specific ID. Here my arguments are no post ID though, but the user input data. My first argument therefore will be an args object. There also is a second argument available, which is the request, by the way. This will become important later. Now on the incoming args object, I can retrieve all the data I define in my schema. So email, name, and password. That is my argument data, so that is what I can retrieve from the args object. Not directly on the args though, instead args will have a user input field because args actually will be an object containing all the arguments passed to that function. Here it's only one, but it could be more. So args will have a user input field, and then there I will have email, name, and password. So I can retrieve them. I can, for example, retrieve my email by typing args user input, because in my schema I named this field here user input. And on the user input, I can get the email. So .email, like this. This is one option. We can also use destructuring to get user input out of my args object. And then the email would just be user input email, so a bit shorter. Now we'll use this in a second. First of all, let's import the Mongoose user model, because I'll still interact with the database, of course. So I will require models user, and then in here, I want to use the async await syntax. To use that, I need to change the way I write this method. I add a colon after create user and use the function keyword, and now I can add async in front of that. So now I can use async await. That is purely optional though. You could also use the normal then catch approach with your promises. Now in there, first of all, I want to find out if that user already exists. And for that, I'll get an existing user by awaiting for user find one, where the email in the database matches the email entered in the user input. Now one super important note. if you're not using async await, you need to return your find one query, which you're executing here, where you then add then, because if you don't return your promise in the resolver, GraphQL will not wait for it to resolve. When using async await, it's automatically returned for you. We don't see the return statement here, but it is there. So that is super important. So now I'm getting my existing user, and if I have an existing user, well, then I know I don't want to create a new one. So in this case, I will create a new error with a message of user exists already, and I will throw that error. And I will come back to error handling and GraphQL in a later lecture. If I do have no existing user with that email address, then I can continue with storing it. And the logic for that is similar to the one in my auth controller. We need bcrypt to hash the password. So in my resolver function here, let me import bcrypt at the top. And then there, we can use the hash method to hash the user input password with 12 salting rounds. Now again, I'll use async await here, so I'll get my hashed password eventually after awaiting for this to finish. Now, after I got that, I can create a new user object, and in that user object, I will pass the email, which is user input email. I'll pass the name, which is user input name. I'll also pass the password, which is my hashed password. Now I need to save that to the database, and I do care about the created user, so I'll store that stored or that created user in a constant by awaiting for a user save. And that will just return that user object it created. Now here, finally, I need to return some data. And we see which data in our schema. We need to return a user object. For that, here, I will return my created user underscore doc field, which contains just the user data without all the metadata Mongoose would add otherwise. And it will override the underscore ID field by adding it as a separate property, and therefore it will override the one I'm pulling out of underscore doc, because I need to convert it from an object ID field to a string field, otherwise it'll fail. So here I will access created user underscore ID and then call to string. This is now the user object I'm returning when I'm creating a user. Now, one important note before we actually try it in our front-end application. We can, of course, try that from inside Postman, but there is an even more convenient solution for testing this. Before I show you this solution, let me first of all clean my database though, so that we start from scratch. And for that, I'll delete both my posts and my users collection here. It will be created on the fly again once I got data to enter, and I simply want to remove all entries I have thus far. So now with the clean database, let me show you that simpler approach I'm referring to. To test this mutation, I can go back to app.js on the backend code, and there, where I register or set up my GraphQL endpoint, besides setting the schema and root value, you can also set graphical, written GraphIQL, to true. This gives you a special tool, and this is the reason why I'm not listening for post requests only here, because now with your running server, try visiting localhost 8080/GraphQL, and this will send a GET request. If you enter something in the browser here, you send a GET request. And you will get this screen, which allows you to play around with your GraphQL API. Now, if you go back to your backend, to the schema, quickly add a query again to your schema here, root query. And let's create that type here real quick. And in there, just add that hello again, like this. We don't need a resolver for that, we just need that query. Now, if you reload your graphical interface, you actually have that documentation on the right here, where you see the operations you can do, but you need to have a query defined for that, even if it leads into the void. And there you can click onto it to see which mutations you have, which data you need to send, and so on. And you cannot just explore that here, you can even send your data. So in here, you can now create a new mutation by typing mu, and you'll even get auto-completion, then curly braces. And now with control space, you even get suggestions. If you have more than one option, it will not be filled in automatically, but you'll get a drop-down instead. You get suggestions for what you can run. And here you now see this needs a user input, then a colon, and then an object that contains the user input data. And there you see we need an email wrapped in double quotation marks, test@test.com. We, let's say, need a name. That could be Max. And we need that password, and that is tester. And thereafter, we add a pair of curly braces, and now we can define the data we want to return after this query is done. With control space, we get some suggestions, like the ID that was generated, or the email. And now you can run this query by pressing that play button up there, or hitting Control Enter. You also see the commands here. And this will now execute it, and it seemed to have succeeded. You see the ID of the created user and the email. And if you go back to MongoDB Compass and you refresh that here, you should have that user's collection back, and you see the user in there with the hashed password. So this is a great tool for playing around, better than Postman, because you got this nice interactive support with the auto-completion. You got the documentation here, and you can test your GraphQL query in this tool in a really nice way. And now with that, let's see how we can enhance this, for example, by adding validation, before we then also connect our front-end application, of course. Now we added our first mutation, and a mutation of course also means that we store data in the database. When something like this happens, we want to ensure that the data we store is valid. And previously in the REST API, and also in the normal Node-Express application where we rendered views, we used Express Validator for that, and we added it as a middleware on our routes. With GraphQL, this is not an option, because we only have one route. This is the only endpoint we have, and we certainly don't want to validate all requests in exactly the same way. So to change that and to adjust it to our needs, we want to move validation into our resolvers. There we have our endpoints, and there is the place where we can now validate our incoming request data. To do validation there, I'll install a new package with npm install and then -- save, and that is called Validator. And that, by the way, is the package which Express Validator used behind the scenes. We can use that directly in our code now. So in my resolvers file, I will import that validator object provided by the validator package. And now in create user, we can add some validation logic with simple if statements. For example, I can check if I don't have a valid email. So not validator, and then is email, and you get the same rules as with Express Validator, because as I mentioned, it builds up on this validator package. And I check if user input email is not an email address. And if that is the case, then I want to store that error. So I'll create my own errors array here, and that's just one way of handling this. You could find a different pattern, of course. And I will push a new error onto this array, and for me here, and that again is only my implementation, an error will be an object where I have a message, for example, email is invalid. Now let's say we don't just want to validate the email, we also want to check whether our password is there and if it's too short. So if validator is empty, user input password, then we have a problem because then we got no values for the password. Or we also have a problem if it's not empty, but if the length is not long enough. So if the length for the password is not fitting the criteria we specify in the second argument to isLength, which is an object where we can set a min and a max key, and I'll set min to 5. So if we enter a password that is empty or not long enough, so if it is not long enough, we need to add an exclamation mark here. Then we make it into this if statement here. And then we also have a problem. And there I also want to push an error onto my errors array. And there I'll add a message of password too short. Now this is just one way of implementing this. Now, after having all these if checks, I can check if my errors array has a length that is greater than 0, which means I do have errors. And if I do, I'll create my own new error object where I throw invalid input, or where I report invalid input, and now I throw that error. Now let's give that a try. If I now try to add an email address, which is not an email address, and I hit play here, I indeed see my invalid input message. And that is how we can add validation. What if we now want to pass more data with our error message here? We added validation, and we see that a failing validation, and hence a thrown error, as we were doing it here, leads to a response that actually has null in the data it gives us back, but that has an errors key with an array of all the errors it gathered. If you open the network tab, by the way, and you re-execute that, you also see that it sets a status code of 500. Now that's nice, but sometimes you want to add more detailed information. You can't set your own status code though, but we could add more information to the errors we return. And to do that, you can go to your app.js file, and there where you configure your GraphQL API, you can add another configuration option, which is called format error. And this is actually a method which receives the error detected by GraphQL and allows you to return your own format. Now, if you just return error, you keep the default format, which is exactly the format we see here. But you can change that, of course. You can check if in your error here, you don't have the original error field. So if you don't have that, hence the exclamation mark at the beginning. Original error will be set by Express GraphQL when it detects an error thrown in your code, either by you or some third-party package. If you have a technical error, let's say a missing character in your query here or anything like that, then it will not have that original error. And if we don't have that, then I'll just return the error that was generated by GraphQL. But if I do have my original error, well then I can extract useful information from it that I can add in other places. And that is what we can do in the resolver now. Let's say validation fails. On the error that gets created here, I could add a data field, which is my array of errors, which I populate here with my validation error messages. I could also add a code here, which is set to 422, or I come up with my own coding system. I don't have to use HTTP status codes here. And now in app.js, I can retrieve all of that from the original error. So I can get my data from error, original error data, and that might be undefined for thrown errors that don't set it, but that's okay. I can retrieve my message directly from the error, because that is already pulled out of the error by GraphQL. And in case that should be undefined somehow, I can set this to an error occurred. And I can get my code from the original error again. There I named that code too, and I could set this to a default value of 500. Now with all that pulled out, I can return my own error object here, where I have a message just like the original one, but where I then also add my status field, which contains my code, and a data field which contains my data. And you can name all these fields in exactly the way you want. And now with that and all the files saved here, if I hit enter again or play again, now I see I get a different error output with the data I added. And this can be very useful, and this is how you can handle errors in GraphQL. Now it's finally time to work on that React application we have as a frontend here, which you also find attached to this lecture again in case you skip the other modules. It's a React application. We'll not work on the code here too much because this is no React course. And now I'm interested in signing users up. This is done in the app.js file there and there in the sign up handler. Here we send a request for creating a new user, but this is of course a request from the REST API world. You learned that from now on there only is /GraphQL for all our API requests, and then here this has to be a POST request. The type is still application JSON and this needs to be set, but the body will now be in the GraphQL query language. And for this, I'll create a new constant which I'll name GraphQL query. The name is up to you though. And this will be a JavaScript object where you need to have a query key. That is required even for mutations. The value here then is a string which you create with double backticks so that you can write multi-line string. Single quotation marks will not do it. And here you add mutation to define that you're running a mutation now. Curly braces and now the name of the mutation. The name of the mutation you want to execute is create user. Essentially, you could just copy this query here now. This is what you could copy and which you could move into your query here. Now, of course, we need to replace these values with the values we fetch from the user input though. And we can do that by using $ curly braces in this backtick enclosed string, because this is a template literal and this allows us to inject values. Now just make sure you keep the double quotation marks around the injected values. Otherwise this will fail because this query language here needs to enclose strings in double quotation marks. Now the email can be retrieved just as we retrieve it down there. So we can copy that code up there. And the same of course also for the name and the password. So for the name, we also inject the value with $ curly braces, and we use that syntax from below, and the same for the password. Let's copy that and replace this with the injected password code. Now here, I'm retrieving ID and email. It's up to you, we don't need any of the data. I'll leave it like this. And now, this is the object I want to stringify, so my GraphQL query object. Now I don't need to check the status code here because that will not be set. It's either 200 or 500. I'll cut it here and I'll remove that, and in the response data then block here where I have the parsed request a response body, there I can now check if response data has errors. And there, on the first error, I could check for the status field. So here, I will check if response data has errors. If that's the case, I'll check if response data errors, and there the first element has a status field, just as I explained, accessing this field. And if that is equal to 422, and then I can throw my validation failed error. Maybe we have other kinds of errors. So I'll check another thing here. In case we don't throw that first error, I'll check just for the existence of errors. And there I would throw another new error where I just throw user creation failed. Like this. Now after these error checks, I'm printing my response data here. And actually we should have all we need to sign users up now. So let's run our frontend server with npm start. It runs on localhost 3000. So let's open that here. And there, let's navigate to the sign up page and create a new user. Now, this is an email address which is already taken, and actually, therefore, I should fail doing that. Let me click sign up, and indeed I get an error, but this is a different error than you might expect. It's an error here where my method is not allowed. And this can be a tricky thing to fix if you're brand new to GraphQL. The reason for this error is we get this error actually as a response to our options request here, not to our post request. Now, you might remember that I explained that the browser sends an options request before it sends the post, patch, put, delete, or so on request. The problem is Express GraphQL automatically declines anything which is not a post or GET request. So the options request is denied. The solution is to go to that middleware where I set up my course headers, and there I check if my request method is equal to options, and if it is our options request, then here I'll return res send status 200. So I'll simply send an empty response with a status code of 200. I return so that this code is not executed, and therefore options requests never make it to the GraphQL endpoint, but still get a valid response. And with that, if I now go back to my front end, I clear my errors, and I sign up again. Now the user creation fails, but now it simply fails, because if we look into our data, we see that the user exists already. And that is what we expected. And now if I take a valid email address, which is not taken yet, it actually succeeds. And here is the response I get back from GraphQL, my data, that is provided automatically for the create user query, the two data fields I requested. And this is how we connect the front end to our backend by simply sending a post request with a valid GraphQL query expression. Now that we're able to create new users, how does authentication work in the GraphQL world? Does it work in a similar way to REST APIs? Do we use sessions again? Well, remember this slide. A GraphQL API is also stateless and client independent. So generally, we still authenticate by using such a token, which we then attach to every request that should be able to access protected resources. And a login action is, in the end, just a normal query where we send some user data and where we want to get back a token, right? So in the end, what we can do here is the following. On our backend code, in our schema, I will now define a real query instead of my dummy placeholder hello query, which I'll name login. Here, I'll need some data. And I could again define my own input, like here I did for user input data, but also to show how to use multiple arguments, I will expect an email, which is a string, and a password, which is a string. And then I will return not a user, but some data that contains, let's say, the user ID and the token, because these are the two pieces of information I happen to need here, and that makes sense as a response. Of course, you could also return the overall user object. So here, I'll define a new type. I'll name it auth data, and that will be my token, which is a string, and my user ID, which will be a string. This is the data I will return when someone sends a query to log in. Now we need a resolver for this, of course. So let's head over to resolvers, and after create user, I'll add my login resolver. There again, I get my args, and I can use destructuring again to retrieve the email and the password argument, which I both get because I define both here in my login query. Again, I want to use async await, so I will turn this into an async function with this syntax. And in there, in my login resolver, the goal now, of course, is to find a user with the right email address and then confirm the password. So first of all, I'll get my user by awaiting for a user find one, where I look for an email address in the database that should match the email I'm getting as an argument. If this is not set, if the user is undefined now, I know that I found no user with that email address, and therefore I can create a new error where I say user not found or whatever you want to set as an error message. I can set a code here, just as I did it for create user, of let's say 404 because we didn't find the user, or 401 because the user could not authenticate. I'll go with 401 and I'll throw that error. If we have passed this if check, then we know that we have a user with that email address. Now we need to check the password. For that we use the bcrypt package and there the compare function. And we pass in the password sent with the request and the stored hashed password. Now, this is an asynchronous operation which gives us a promise, so we can await that and I get back the is equal response. Now, if it's not equal, then I know the user entered a wrong password, so I can create a new error here where I say password is incorrect. And I can also set an error code of 401 here, and then also throw that error, of course. Otherwise, both the email exists and the password is correct, and now I can generate a token. And for that, I'll again import my JSON Web Token package by requiring JSON Web Token here. And then down there in the login resolver, I will generate a token by running JWT sign. Here you now pass the data you want to encode in the token. That could be your user ID, which you get from user_ID to string to convert it to a string. Maybe you also want to encode the email by getting that from the user you retrieved from the database. And the second argument to the sign method then is your super secret, which you use for signing the token, which you then also use for verifying it, something we'll do later. And I'll configure the token with the third argument by setting the expires key in that object you pass to the third argument to 1 hour, so that the token expires after 1 hour. That is exactly what we did in the REST API section 2. Now I will return that token in a token key and make sure to match that schema you defined here. So token and user ID is returned. So in the resolver, we return the token on the token key and the user ID, which is again my user_ID to string. And now with that, we have a login query in place where we send like a GET request to log the user in to get the token and so on, you could say. Now we need to wire that up to the front end in the next step and then of course test it. If you're feeling bold, also try it on your own, of course. Did you try it on your own? Well, let's wire it up together. For that, in the front end, we need to go to the login handler, which is where we do login users. In the login handler, I need to send a request to /GraphQL, of course. It's a POST request. And now I'll define my query. So my GraphQL query. You can name this constant however you want. It's a JavaScript object with the query keyword, and then a string that defines the query. And for a normal query, you now don't repeat query, you just start right away with the curly braces, as we did it in the graphical interface earlier. Now, let me split this over multiple lines to make it easier to read. In that query here, I want to reach out to my login query. So to that query, I defined in that schema, login. I need to pass email and password here. So login actually gets curly braces here. And the email, between double quotation marks, will be the email I also extract down there auth data email in this case. The second argument, separated with a comma in this function-like call here, is the password, also enclosed between double quotation marks, and there you inject auth data password. Now, we can get back some data, which we enclose between curly braces. And the data we get back, well, there I'm interested in both the token and the user ID. So I specify both between these curly braces here. That is the query I want to execute, and that is the data I pass to JSON Stringify on my request body here. Now, as you learned, checking the response like this will not work. Instead, we can grab the code we used for signing up, this code here, and copy that over in the login handler. We therefore remove these checks in the first then block. In the second then block, we now add the copied checks. And here I just will say user login failed because creation doesn't make much sense here. Thereafter, we set the state, and the way we retrieve data from the response will not work. I can already say that. Now, why will it not work? Well, for that, let's first of all run the query in the graphical interface. There, let me get rid of that mutation. Instead, let's run a query. You can also omit this, by the way. And in there, it only sees hello. I need to reload. It now sees login. Let me specify the valid email, which I did use for the user, and the password. And now I want to get the token and the user ID. If I now hit Control Enter, I do get my data here, and I do get it on an object which has a data field that is always added by GraphQL. In there I have the name of my query, which was login, and in there I have my response data. So this is my REST data object in my React code though. So REST data will be this entire object. So if I want to get the token, I need to drill into it, into data login token. So in the places where I just access REST data token, I instead need to do REST data login token. And that is now the case for all the places where I retrieve something from the response data. I need to add data login. With that in place, if I now save that front-end code, and the backend should be saved too, of course, we can go back to our app and try logging in here. And indeed, we then get an error for fetching the posts, which makes sense because we try to use a REST API URL, which does not exist. But logging in actually succeeded. So we got user sign up and log in place. We now need to add some routes for, or some endpoints for getting posts and for adding posts, of course. And we then also want to use that token we do get to protect certain, but not all, GraphQL endpoints. These will all be steps with which we continue. Now that we have users in place, let's work on posts. And for now, I will add posts without a real image, because the image upload is something I'll manage differently. For a post with just title, content, some dummy text for the image URL, and an attached user, you can definitely try this on your own, though that will be challenging, of course. But give it a try, go as far as you can, and then try to solve it together with me. I will, of course, now also do it with you. So I will start in my backend, in my schema here, and I will add a new mutation, create post. There I expect to get some data that describes the post. We could either get it all as separate arguments, or again, we define an input type, which I will do here, and that will be my post input data. And in my post input data here, I will require everything I need to, well, create a new post. And I expect that to be a title, which is a string, the content, which is a string, and also the image URL. The user is something I can retrieve from the token, which has to be attached at some point anyways, and the image upload is something we'll handle differently later. So the post input data is in the end what I get here. So post input will be of type post input data, and I will return the created post here. Remember that we did create that post type earlier already. And now with that, we can actually already move on to the resolvers and add a new resolver which I'll name create post. In there, I can use destructuring to extract my post input argument, which I just defined in my schema here. And I do get the request as the second argument. We'll need that later to get the user data. Now, for now, let's simply create a dummy post with the dummy data we are able to use right now. And of course, let's also validate the input. For validation, I'll use the same approach as when we created or logged users in. I'll create an empty array, an empty errors array, and then I'll add a couple of if statements. Here I'll check if validator is empty, so if the input is empty, and I'll check that for my title. If that is the case, or if we don't meet a minimum length requirement with isLength for the post input title, and then I configure this length with the second argument to be a minimum of 5 characters long. If we have either of these two cases, then I'll push a new object onto my errors array with a message of title is invalid. Obviously, again, you could be more detailed here. So that is my title validation. I'll then add another if check where I check the content for exactly the same two things, and that is it for now. Now with that in place, I'll keep my code I have up there where I have a look at my errors length, and I will copy that down here too to throw an error if we have any validation errors. If we make it past this if block here, I know my input is valid and we can now create a new post. For that, we'll eventually also need a user, but for now I'll ignore the user, and instead here up there I'll import my post mongoose model from the models folder, and now we can use that to create new posts, which you of course do, not user, post, by using our constructor mongoose gives us. Now I want to use async await again, so I'll tweak that to use this syntax here. And now, down there where I create my, my new post, I pass in the title, which I get from post input title. I of course also add the content here, so post input content, the image URL, post input image URL. And for now, I won't add a creator here because I'm not able to retrieve the user yet. So that is my post. I can now store the created post in a new constant, and I get that by awaiting for post save to finish. Here, I'll then also need to add post to users posts later once I do also retrieve the user. For now, I can just return my response here, so to say, by getting all the data from the created post doc, and then I'll overwrite the ID because I can't return the MongoDB object ID. I need to return a string, and I also will overwrite created at and updated at because these will be stored as date types. GraphQL does not understand that, so I need to convert that to a string too. So I get that from my created post, there, created at, and I need to call to ISO string here. The same for updated at. Updated at will be created post, updated at to ISO string. And now with that, this is the data I want to return when a new post was added. Now for now, I'm not checking if the user is authenticated and so on. I'll just have this resolver added, this create post resolver for the respective mutation. Let's try that out in graphical, first of all. So here, if I reload that so that it loads my latest definition, I can add a mutation here, and that is now create post. There I have my post input, which is an object, where I have a title, test, where I have a content, test, and where I have an image URL, some URL, and where I then, once it is created, can get back the ID and the title, let's say. Let me click on Prettify to make this a bit easier to read. And now if I hit the play button, I get invalid input, which makes sense because title and content are too short. So let's make them 5 characters long. And now I simply get an error from the database that the creator is missing, which makes sense. But the general mutation is working. Let's now make sure we also validate that token, which we need to send anyways, and that we extract the user ID and the user therefore, so that we can connect posts and users. And thereafter, we'll of course also connect our front end.